Imagine looking up on a clear night and watching the moon simply vanish. There is no flash or debris, just the sudden removal of a celestial body that has been our constant companion for 4 billion years. While astronomers might appreciate a night sky free of lunar glare, the absence of the moon is not a cosmetic change. The moon is a gravitational anchor, exerting a massive, constant pull that has stabilized Earth's rotation since its infancy. When that tether disappears, the physical result is a massive gravitational shift. Earth's interconnected systems begin a violent transition. This moment marks the beginning of a sequence of environmental shifts that will alter the physical characteristics of our planet. Within hours, the environment changes. Without the reflection of sunlight from the moon, nights become significantly darker, lit only by the faint glow of distant stars. For species like sea turtles and coastal crabs, this change is a survival threat. These animals rely on the specific intensity and position of moonlight to navigate the shoreline and find nesting grounds. High above, migratory birds use lunar cycles as a primary navigation tool during their seasonal journeys across the globe. In a matter of days, the sudden loss of lunar light disrupts the biological rhythms of these nocturnal ecosystems, leaving them unable to navigate or reproduce as they have for millions of years. As weeks pass, the impact reaches the global ocean. While wind still creates surface waves, the massive rhythmic rise and fall of tides fails. This top-down view shows the mechanism. The moon's gravity pulls Earth's water into a tidal bulge. As the Earth rotates through this bulge, we experience the transition between high and low tide. Without the moon, this bulge collapses. The tides do not vanish entirely, the sun still exerts a pull, but they lose nearly 2/3 of their height and power. Coastal ecosystems, from salt marshes to mangroves, rely on the aggressive daily churn of these tides to transport nutrients and oxygen through the water column. By losing its primary tidal engine, the Earth sees a reduction in the nutrient cycling that sustains the shorelines where marine and terrestrial life meet. The most severe physical consequence takes thousands of years to manifest, as we look at the very posture of our planet in space. Earth currently spins at a 23.5-degree tilt. As this diagram shows, the moon acts as a stabilizer, preventing the planet from tipping too far in any direction as it orbits the sun. The moon's mass creates a gravitational lock that keeps this angle consistent over vast periods of time. Without this counterbalance, the Earth begins to wobble. Over millennia, the axis can swing to extreme angles, potentially tilting the planet nearly on its side. Our seasons are defined by this tilt. When the angle changes, the distribution of solar energy across the planet shifts with it. The ultimate result of a missing moon is the loss of climatic predictability. On a wobbling Earth, seasons as we know them disappear. A region that has been a frozen tundra for centuries could shift into a scorched desert as the planet's orientation to the sun changes. Polar regions might experience months of direct, intense heat, while equatorial zones could see their temperatures plummet, shattering the climate patterns that human civilization is built upon. While scientists would search for the cause of the disappearance, humanity would be forced to adapt to a planet where the environment is in constant, unpredictable flux. We often view the moon as a passive observer in our sky, but it is actually a primary driver of Earth's habitability. If this gravitational anchor vanished tomorrow, how do you think humanity would adapt to shifting tides and an unstable climate? Share your thoughts in the comments below, and be sure to subscribe for more deep dives into the science of what if.